lah kalau kat rumah line tak stable. Sampai mana tadi? Dah tahu tak macam mana dapat centroid ni?
Sampai lukis.
Sampai lukis ya, lukis dotted line ni?
Ya.
Yes.
Okey, bagus. Okay, so baru saja ya. So the centroid is here. We draw the X bar represented by the dotted vertical line here, and no.
Prof tak nampak slide.
Slide.
Oh, okay, hold on. Oh my God. Okay. Nampak kan?
Nampak.
Okay, so we draw the X bar. X bar is 250 mm represented by this vertical dotted line here. And the Y bar is 75 millimeters represented by the vertical horizontal line here. And then at the interconnected point here, intersection point here, we get the centroid represented by this dot. Okay, is there any question? Do you have any question?
No, Doctor.
Okay, very good. Okay, now centroid for simple areas. We have 4 simple areas here. The triangle, the centroid is given by X bar equal to B over 3. Yeah? 1/3 of base will give the X bar, while 1/3 of height will give the Y bar. The formula for area is half BH. We also have semicircle. Semicircle here, the X bar is 0 because the X bar now is on the Y axis. The Y bar is 4r over 3 pi. R is the radius of the semicircle. Area is pi r square over 2. Pi r square over 2 because it is a semicircle. If it is a circle, it is pi r square. And then we have quarter circle. Quarter circle, the area is half from the semicircle, so we have pi r square over 4. The X bar now is 4r over 3 pi, and the Y bar is also 4r over 3 pi. For rectangle, the X bar is B over 2, the Y bar is H over 2, the area is BH. Now, centroid of composite area. Now we have composite area. Composite areas are the combination of simple areas. We have 2 simple area now. The rectangle, horizontal, and the vertical rectangle combined, we come up as composite area. The determination of centroid is much more easier if it is calculated using the table. Yeah. Follow this step. Yeah? Step 1, divide the areas into several parts. Okay, we can name the horizontal one as part 1, for example. And we can name the vertical triangle here as part 2. Okay. Okay, second, state the reference axis in the figure. Okay, you have to, if it is not given, you have to determine or you have to establish the X and Y axis. It could be here. Okay, it could be here, yeah, the x-axis. It could be the y-axis could be here. The x-axis could also be somewhere else. It could be here. Okay. The y-axis could be here. Okay. And the combination could be also like that. Could also be like this. Yeah. So we will see how to solve this with various location of the y and x axis. Okay, step 3, once you have established the reference axis, you can proceed to find the x bar and y bar. In this slide, it doesn't show x bar here. I think because it is quite tedious to draw the line above the x or above the y here. After that, step 4, find the centroid. The centroid is determined from, again, this formula. X bar is equal to summation of area times x bar divided by total A. It's actually like this, yeah. X bar is equal to summation of A x bar divided by summation A. Okay, that is how we should write the formula. Same with y bar. Okay, now example 1. Let's try to solve against example of simple area rectangle, but now with various x and y axis. Okay, for this triangle, we know that the x bar now is 6/2, which gives us 3 meters. The y bar, since the x bar is at the base here, so the y bar now is 4.5 divided by 2, we have 2.25 meters. Okay, now we change the y-axis from here to the middle here. So we know that x bar must be 0. Okay, so x bar is 0, whereas the y bar is still 2.25 meters. Okay, now we have both x bar and y bar go through the centroid here. Okay, so we have x bar equal to 0 because it is on the y-axis, and y bar is also 0 because it is on the x-axis. Okay, now let's look at example 2, finding the centroid of composite area T section. First, we divide the areas into simple shapes. The vertical one is section number 1, and the horizontal rectangle now is number 2. State the reference axis. We put the x-axis at the base here and the y-axis at the left edge of the web. Okay. If we have a T section here, we often refer insert. We refer this section as the web. No, flange. Okay. And here is the web. The vertical one is the web. Okay. We draw the table. Draw the table with 1, 2, 3, 4, 5, 6. 6 column and 4 rows. We have section, area, x bar, y bar, a multiplied by x bar, and a multiplied by y bar. Okay. So section 1 now. Section 1, we have what is the area? The area now is 30 times 120. We have 3,600 millimeters square. Area number 2, we have 150 times 20. We have 3,000 millimeters square. Now let's look at x bar. X bar, we draw the line here. We draw the line at the center. Okay, we draw the line at the center. So for x bar, for section number 1, we have x bar is this one, 300, what is this? 30 millimeter, half of 30 millimeter, or half of 150 millimeter, which is 75. Okay, this is the okay, this is the distance of the x bar. Okay, that is the x bar. Okay, the distance is measured from the dotted line here to the y-axis. So it is 75 millimeters. It's the same with section number 2, where we measure the x bar from the dotted line here to the y-axis. Okay, now y-axis, y bar, we go for section 1 first. Okay, for section 1, we draw at its center here. Okay, and then we measure the y bar. From the dotted line to the x-axis. So we get 120 over 2. 120 over 2, we get 60. This is the y bar. This is the y bar for section number 1. For section number 2, again, we draw the dotted horizontal line at its midpoint here, and then we measure the y bar from the dotted line here to the x-axis. So we get the y bar now is 130 millimeter. 120 here and then plus 10, 130 millimeters. Do you have any question?
No, Prof.
No, Prof.
Good. Okay, now after we have obtained the x and y bar, we can calculate the ax. Ax is 3,600 multiplied by 75. We get this value, and in a similar manner, we get all the rest of the values. And we need to sum up all the ax values and ay values here. And also the A values. So from this formula, we get X bar equal to 75 mm and Y bar equal to 91.82 mm. X bar now is on the vertical dotted line here, 75 mm, whereas the y bar now is located at 95.82. 95.82 is somewhere around here. Okay, so the centroid of this composite area is here. Okay, that is the centroid of the composite area. Okay, now we go to the next example. The difference now is we have a hollow section. Part number 3 here is a hollow section. Okay, a hollow circular with diameter 20 millimeter. Okay, so we create a table with the previous details of section 1 and 2. This is from the previous detail, yeah? 216, 390, similar. Everything similar for section 1 and 2. Now we have to add the hollow section number 3. Part 3, hollow here, the area is pi r square or pi times 10 square. Pi times 10 square gives us 314.16 millimeter square. But since it is hollow, we have to add the negative sign. Okay, we have to add the negative sign so that the total area now will be less than what we have from the previous example. From the previous example, we have total area of 6600. Now with the hollow inside, we have less area, which is 6285.84. Okay, the X bar now, considering the hollow is located at its center of section 1, we have the okay. Okay, we have the dotted line to represent the X bar. So the X bar for segment number 3, hollow here is again similar, which is 65 mm, and the Y bar is similar with part 1, yeah, which is also 60 mm. Okay, then we get the AX with the minus 314 here. We will have minus AX and minus AY. And we sum up all the AX, sum up all the AY, sum up all the A's. We get X bar equal to 75 and Y bar is slightly higher than the Y bar before. Okay, 93.41. Let's see the previous example, 91.82. Okay, so this is slightly higher. Therefore, the centroid is also slightly higher for this composite area with a hollow. Okay, that is the centroid. Okay, example number 4, we have a similar composite area with a hollow, but then we change the reference of axis. The x-axis now from the base to the connected surface between area 1, 3 and area 2. Okay. So we have now look at segment 1 or section 1. The X bar is all 75 here for all parts or sections. The area is still negative because it is hollow. The Y bar now is different. Okay, the Y bar for part 1. Okay, let's draw the line. Okay, this is the Y bar for part 1 and part 3. Yeah? When we draw the Y bar there, we measure the Y bar from the horizontal line just now to the x-axis. Okay, here. So the x-axis here is where y is 0. Now the y bar is below the x-axis, so it is 120 divided by 260, and it will be negative because it is below the x-axis. Okay, so the y now is negative 60 for part 1 and part 3. For part or section number 2, the Y bar is here, and when we measure the distance from the horizontal line to the X bar, we get Y bar now is positive 10. Okay, 20 divided by 2, we get positive 10. Okay, then we multiply the AX again. We get this one, AX1, AY1, and total A. Inserting all the values here into these two equations, we get X bar equal to 75 mm. Okay, now the X bar is there, 75 mm. The Y bar is negative 26.59. That means it is below the X axis for negative 26.59. Okay, so it is somewhere there. The negative 26.59 is measured from the y-axis to the centroid here. Okay, so the centroid now is here. Okay, it is in a similar location as a previous example. Okay, finally, let's see how we are going to find a centroid for 3D body diagram. This is the example of 3D body diagram. You are basically having 4 different parts, yeah? The rectangle, okay? You take out the rectangle and then you have a quarter circle, okay? And then you have a circular hollow here, keluarkan. Okay. Now, before we solve an example for that, let's see how to determine the center of mass or center of gravity. The difference between calculating the centroid using volume, mass, or weight is simply a scale factor. Yeah? Since mass and weight are proportional to volume, as indicated below. So when you want to solve for 3D, one dimension just now example is a rope or line. 2 dimension is a composite area. Now 3 dimension, you have to deal with volume, because instead of just having base and height, you also have the thickness. So now volume come into picture. Okay, this symbol here is called rho. Rho is used to assign a mass density. Mass is in a unit of kilogram per meter square. Okay, so M is given as rho times V. We have rho in kilogram per meter cube multiplied by volume. Volume is in meter cube. So this meter cube and meter cube cancel out. We have mass in kilogram. Okay. Gamma, okay, this symbol here is gamma. It represents the weight density. M represent the mass, M represent the mass, rho represent the mass density, gamma represent the weight density. You need to know this because when you deal with concrete, you always deal with mass density. But if you, let's say, want to design a water tank, so you have to consider the weight density, gamma, okay, gamma here. So weight density is also given as m times g. Okay, m times gravity. M just now is rho v. So we have rho vg or rho gv. Okay, with gamma equal to rho g, we also have w as gamma v. Okay. The centroids for mass and weight can be found as follows. We use the same equation just now. We have x bar here. X bar, if we consider mass, centroid for mass, we have x bar equal to mass times x bar divided by total mass. If we have weight, centroid for weight, we have x bar equal to summation of x bar times weight divided by total weight. Okay. Okay, this is the formula for several shape of or several 3D object. Yeah, we have hemisphere. Hemisphere is half of the sphere. The x bar is given as 3a over 8. The volume is given as 2/3 pi a square, where a is the radius of the cross-section area here. Semi-ellipsoid of revolution here, semi-ellipse, yeah. The a is the radius of the cross-section of the surface here. The x bar is given by 3h over 8, where h is the height. And the volume is given as 2/3 pi a square over h. When we deal with paraboloid, the x bar is h over 3, and the volume is half pi a square over h. We also have cone. Okay, cone here. The h is the height. The x bar is h over 4, and the volume is 1/3 pi a square h. Lastly, we have pyramid. Pyramid here we have centroid is equal to h over 4, and the volume is 1/3 abh. Okay, finally, the final problem now is 3D, where we need to solve for x bar, y bar, and z bar. Okay, we have two blocks of different materials, and they are assembled like this picture. Okay, the weight densities of the materials, since the materials are different from A and B, the density of A is also different from B. The density of A is given as 86.8 kilonewton per meter square, whereas the density of B is given as 260.4 kilonewton per meter cube. Sorry, not meter square, but meter cube. Find the center of gravity of this assembly. Find the center of gravity of all of this composite object. Okay, in this problem, the block A and B are considered as two segments. Okay, we have weight equal to W equal to P times volume. P times volume just now is mass, yeah? Okay. Mass equal to M. Let's see again, the two blocks are of different materials, okay? We can use weight, we can use mass, but when it use rho times volume here, rho times volume, volume is in centimeter square. Okay, I small the font. Okay, rho times volume. Rho times volume will give you mass. Okay, let's see. Now 86.8 is rho is in kilogram, yeah. Oh, this slide has so many mistakes. This is kilogram. Okay, so this is kilogram per meter cube. Multiply by the volume. The volume now is already in meter cube. Okay, because it divides it with 10 to the power of 3. Okay, so we have 3.125 meter cube, and meter cube cancel out. We have 3.125 kg. Okay, now the area of A, the volume of A is, this is not WA, this is MA, this is MB. Okay, the volume of A is half, because you see, look at the MB first. Now let's look at the MB first, mass of B. B now is a rectangle, or like a box, yeah, 260.4 kilogram per meter cube. Okay, let me see who sent me this. Again, I left the meeting. OMG.
No, Prof.
No,
Huh?
Prof. Ada.
No.
No problem.
Ada lagi ni.
Oh, ada eh? Okay,
Ada.
okay. Thank you. Okay, now first let's look at part B, yeah? Part B, block B there. 260.4 kg per meter cube times the volume. The volume now is 6 times 6 times 2. 662, and then this is already in meter cube. So we have 18.75 kg. Okay, now only we look at block A. Block A is half of the block B. So it is half rectangle. Therefore, we have the volume as 6 times 6 times 2 times half. Okay, times 0.5. So we have 3.125 kg when we multiply it with the density. Okay. Okay, now we draw the table. Segment of part A, just now we have 3.125 kg. Okay, segment B, 18.75. So the summation of M now is equal to 21.88 kg. Now let's look at X bar for part B first. Yeah, let's look at part B first. The X bar, X is this. Okay, this is the x-axis. So the x-axis, the length of the B, the length or the width of B now is 2 centimeter in x-axis. 2 centimeter in x-axis, that means the centroid now is 1, yeah? 2 divided, we take the center, it becomes 1. Yeah, that's why we have 1 here. Okay? Meanwhile, it's y-axis now. This is the y-axis. The length of the y is 6 centimeter. So we cut it half, we get y bar equal to 3. In a same manner, for the z-axis now, here the z-axis, we have length, total length in z-axis is 6 centimeter as well. So divide by 3, divide by 2, we have 3. Okay, you understand for part B?
Yes.
Yes.
Yes. Thank you. Now let's go to part A. Part A, the x-axis now. The x-axis is 6, yeah? 6. Now let me draw the triangle, yeah? Triangle. When we have a triangle like this, it is more like this, 6, 6. Okay, when we have triangle like this, the centroid is somewhere, must be somewhere here with, the x bar should be equal to its base divided by 3, 1/3 of its base and 1/3 of its height. Okay, now let's see. Part A, the x bar. The x bar, the length of x now is 6 centimeter. 6 centimeter. This is x. Okay, the red one is x. The x now is 6. So we take 1/3 of 6. We should get 2, not 4. Okay, we should get 2 here, not 4. Yeah? Now let's move on to y bar. Y bar is y is 6, yeah? 6. No. Y now is 2. 2 centimeter here. 2 centimeter. We do not see in the triangle. We take half of the y length, we get 1. Okay? And then the z-axis, now I have to draw this.
Prof, can I ask a question?
Yes. Please ask.
The x-axis must add up the two from B segment because x-axis of A is 4, right? Because 2 plus 2 is equal to 4.
Wait. x-axis of A.
Yeah.
X-axis of A is 2 here, 2. Okay. Why do we have to add it up?
Because from 0 is from the
Wait,
B.
no. Wait. The x-axis is 6, yeah? 6. Oh, okay. No. I understand. Correct. You are right. Because we have x-axis 6 and we plus 2, yeah?
Yeah.
Yes. Okay, thank you very much. That's why it gets 4 just now. Okay, thank you. Okay? Betul?
Betul.
Yes.
Betul.
Okay. Okay, thank you. Okay. So this is the x-axis 4 and z-axis here. We have 6, yeah? 6. So 6 divided by, I take 1/3 of 6, we get 2. Okay? So correct.
Doctor.
Yeah.
Sorry, Prof.
Yeah.
The two is from the segment B, right?
Which
The 2
2?
second.
This one, 2.
No, the x-axis.
X-axis is now 4.
Why 4?
Why 4? Because you see the x-axis now x here, right? So the distance in x-axis for part A, okay, 6 plus 2.
The 2 is from segment B, right?
Okay. Okay, just siapa yang cakap dengan I awal-awal tadi? I know you thought 2 plus 2 centimeter, ya. But the subject, the part A stops here. Betul. 6 cm only. So again, it must be 2. Ayo, I'm so
Prof,
confused now. Yes.
It's 3, right? 3.
If
No, cannot be 3. You don't take half. You take 1/3 for triangle.
Oh, okay.
Prof, if from section A,
Okay.
divided by 3 is 2, right?
Yes.
Then we added up the section B is 4. Because the axis is from the section B.
Yes. You again. Correct. Yes. You are correct. I'm so sorry. I'm so not myself today. It's
Yeah,
for
okay, Prof.
Okay, next time when you want to say something, tell me your name so that I can differentiate, I can call you back. Okay? Okay, your name?
Victor.
Okay, Victor. Just now the girl, you want to ask something? Everyone else, do you get where I did wrong just now?
Prof, can you explain how to get 4?
Okay, what is your name?
Farina?
Farina, yeah. Okay, now let's see x-axis, yeah. X-axis is in red. So when I draw the triangle, the x-axis is in red here. Let me draw again the x-axis here. Oops. Okay, this is x-axis. Okay, Farina. Now, cuba you tengok jarak untuk x-axis, untuk paksi X bagi segmen A. Berapa jarak dia?
6.
Okay, 6. So, I draw 6 here. Okay, now 6. 6, yeah, from the end of the triangle to the beginning of the triangle. So the centroid for the triangle is given as 1/3 of its base. 1/3 of its base is 6 divided by 3, which gives us 2. So this is the centroid. Oops. Okay, this is the centroid now. Okay. Okay, the centroid now from this point, which is this point. Okay, from this point, yeah. Oh, so small the point. Okay. This point here is here in this triangle. Okay, it is 2 meter. 2 meter there. But then the axis, the y-axis is 2 meter some more here. We take the distance x from the y-axis. This is the y-axis. You see? Okay, Farina? We have 2 centimeter as a result from 6 centimeter divided by 3, and then we have to plus the 2 centimeter here to reach the y-axis. That's why we get 4.
Alright, Prof.
Okay, thank you. Now everybody else, ada tak soalan? Okay, if you don't have any more question, so the details here, the values here are all correct. We get the summation of m in kilogram, 21.88 kilogram. The x bar for each segment is given here, the y bar and the z bar. Now we multiply the m with the x bar, we should get kilogram, centimeter. Okay, this is also kilogram, centimeter, and this is also kilogram, centimeter. These are all should be M. M kilogram centimeter. So by inserting all the values in the equation, we get the x bar equal to 1.47, y bar equal to 2.68, and the z bar equal to 2.82. Okay, let's see where it is situated. 1.47 x bar. Okay, somewhere here. Y bar 2.68. 2.68. Okay, let me see. Y bar 2.68. Y bar, so somewhere here. Okay, and then x bar 1.47. X bar 1.47. No, this should be there. Y bar 2.68. And the z bar now 2.82. Z bar 2.82. Anybody of you have idea where the centroid is? X
Prof, the
bar.
x-axis shall be at the segment B.
Okay, x-axis. Is this correct? I draw the x-axis here. No,
That is Y.
that is y. Y is 2.68.
2.68. Yeah,
So,
that is correct.
so here, yeah. Okay. So the x-axis now is it?
This one.
Yeah, this one. This
At
one.
segment B. 1.47.
Okay, this it goes here. So this is z-axis.
Yeah.
So correct now? Z-axis is
Z-axis shall be
2.82. So is it logic here?
Dr.
Somewhere.
Prof,
Yeah.
the z-axis shall be vertical.
The x-axis.
Z.
Z-axis should be vertical?
Yeah.
No. Shouldn't it be horizontal like this? The z dimension is vertical, so it's centroid. Yes, it should be vertical. Yeah, vertical. Vertical 2.82 at 2.82. I'm so confused now. Let me do it later, and I will inform later. Who just talked to me just now?
Victor.
Okay, Victor again. So Victor, which one is correct and which one is wrong here?
I think correct.
Correct, yeah.
I think lah.
Because it's kalau kita tengok, adakah dia berada di luar atau di dalam box di Centroid? Y X dulu. Kalau kita tengok X dia adalah di dalam, ya, di dalam box kan? 1.47. It's inside the 2 centimeter, kan?
Yes.
Yes, dia di dalam. Y bar pula, kita ada panjang Y bar 6 cm. Tapi kita ada panjang Y 6 cm, tapi dia berada di dalam juga 2.68. 2.68 betul sini. Z 2.82 pun dia berada di dalam. Okey, dia berada di dalam. Maknanya dia somewhere here. Somewhere here. Okay.
I think Z axis is horizontal.
Itulah Z axis, ya. Z axis is horizontal. Yes, it is horizontal. Okay. It's somewhere there, but you cannot see it because it's inside the box. It must be inside the box. Okay. Very difficult to see. Only if you model in 3D in the software, you can see exactly the node XYZ where it is. Okay. So this is an example where when you deal with 3D, it is quite impossible for you to do it manually. It is so difficult to visualize. Okay. So I hope this class today give you some idea of how to determine the center of gravity and how to determine the centroid. We will continue again next week with some more examples. Okay? So before we end this class, is there any questions, any permintaan ke apa?
Prof, I have a question.
Okay. What is your name?
Victor.
Okay. So what is your question?
Prof, can I see back the example of center of mass?
Which slide?
In front, I think it's 5 or 4 page. This one.
This one. Okay.
The next
Fifth.
one.
Okay. Yes.
Prof, if the mass of the third one shall be considered or not?
Kalau ikut yang dia bagi di sini, they don't consider.
But I researched at Google, they consider the mass of the third one.
Okay, I think the Google specifically refer to the particles which are combined together. Okay, but these particle here are not combined. They are on their own. You know, it's separated particles. Okay, that
Okay.
is my opinion. I strong. Yes, yes.
Another question is the triangle one, the center of line one.
Which slide?
Mm, 8 or 9.
8 or 9. Okay.
This one.
Okay. Uh-huh.
Prof, why the CB shall not 650 divided by 2? Why take 300?
Oh, the 300 is not for the CB. The 300 here is for the centroid for AB. The Y X bar. AB for AB 300.
Okay, I know the center of AB is 300, but the next slide is CB also noted as 300.
BC is also 300. X. Oh, okay. BC, yeah. BC, it is diagonal. So we need to find the X bar and Y bar, not the middle length. The half of its length is 650 divided by 2. Should be 325, right?
Yes.
It's mid length. But the X bar is 300 millimeter. Okay, remember whenever we have diagonal, we have to what? We have to divide it into X and Y component. That is why for its X, we consider its X direction. Its X direction is AB. So the centroid for AB is 300. Okay, BC is diagonal. Let me draw. This is BC. Okay, when we have any diagonal with a degree not exactly on x-axis and y-axis, we have to divide it into both component x and y. So this is the component x. Component x and component y. So the BC, its x component is equal to 600 millimeters. That's why we have its x bar 300 millimeters. Its y component is 250 millimeter height. So that is why the y bar is 125 millimeters. It's as simple as that. Yeah.
Okay, thank you, Prof.
Okay. Who else? Okay, if you all don't have any more questions, thank you very much for attending and being attentive to my class today. I hope I can share my knowledge, convey the content of this chapter as accurate as possible, even though I don't have the aids like the whiteboard to explain in detail to you. I really appreciate you all attend this class and being so attentive. Thank you very much, and we'll meet again next week, yeah, at the same time. Take care and stay safe, everyone.
Alright,
Okay,
Prof.
Prof.
Thank you.
Okay, bro. Thank you,
Okay,
bro.
Thank you.
Okay.
Thank you, Prof.
Thank
Thank you, Angus.